Hi, today we'll be looking why the interior angle sum of a polygon of n sides is given by n minus 2 times 180. To do so, we'll find the connection between the number of sides, the number of diagonals, and the number of triangles of a polygon. We'll start off with a quadrilateral, which is a four-sided polygon. If you take one vertex and draw in a diagonal, there's only one diagonal that can be drawn in a quadrilateral, but as you can see, the diagonal divides the quadrilateral into two triangles. So one diagonal, two triangles. Now we do know that the sum of the interior angles of each triangle is 180 degrees. Since we have two of such triangles, the sum of all the interior angles of a quadrilateral is 2 times 180, which is 360. Let's look at another polygon, in this case, a pentagon, five-sided polygon. Again, selecting one vertex, we can see that this time we can draw two diagonals. 1, 2. Creating three different triangles. So in a pentagon we have two diagonals, three triangles. Once again, each of those three triangles has an interior angle measure sum of 180 degrees. So to find the interior angle measure of a pentagon, it is 3 times 180, which in this case that equals 540. And likewise, we can do it for a hexagon. Hexagon, which is a six-sided polygon. We can see that we can draw in three diagonals, which creates four different triangles. Again, each of those triangles has an interior angle measure of 180. So the interior angle sum for a hexagon is 4 times 180, which is 720. And the same thing happens for a heptagon. We have four diagonals, five triangles. And the interior angle sum for a heptagon will be 5 times 180, which is 900. We'll put this information into a chart form just to see if we can find a pattern. Again, a three-sided polygon, a triangle here, has one triangle, so the interior angle sum is 1 times 180, which is 180. For a quadrilateral, four-sided, we have two triangles, so the interior sum is 2 times 180, which is 360. For a pentagon, we have three triangles, and the sum of the interior angles is 3 times 180, which is 540. And then for a hexagon, we had four triangles. 4 times 180 is 720. Let's just skip down a few and check what the pattern would be for a decagon. If we had a decagon, which is a 12-sided polygon, if we observe what is happening here, three sides, one triangle, four sides, two triangles, 5 sides, 3 triangles, and 6 sides, 4 triangles, we can see that the number of triangles is always 2 less than the number of sides. So for a decagon, it would be 2 less than 12, which is 10. To find the sum of the interior angles, we take the number of triangles that we had and always multiply by 180, since each triangle has an interior measure of 180. So 10 times 180 in the case of a decagon is 1080 degrees. So following the same pattern here, if I take just generally a polygon with n number of sides, what we are doing from this column to the second column is we are taking the number of sides and subtracting 2, so we get n minus 2. And then we're taking that answer and multiplying that by 180. Therefore, if a polygon has n sides, then the sum of the measure of the interior angles is n minus 2, which is the number of triangles, times 180, which is the interior angle measure of each triangle. I hope that helps.